Saving Energy with LEDs by Vern Utek and Ethan Fry.
Have you ever wondered how you go about saving some energy on the electricity bill? Or just being more energy conscious? You consume energy in a number of different ways today, but 11% of that energy gets used in creating light. This is more energy than refrigeration, electronics, and other appliances. A good way to start saving energy is by looking at what is supplying the light that you use every day. Today, light comes from many sources. Normal lights with filaments, called incandescent lights, fluorescent lights, halogen lights, and more. A newer light source is called an LED, which stands for light emitting diode. LEDs are all around you and keep getting more popular as researchers discover how to make them brighter, more energy efficient, and cost less. You may find LEDs in your alarm clock, light bulbs, as the flash on your phone, on your car, in stoplights, and now even on your TV and computer monitor. Throughout this short video, we'll briefly discuss how LEDs work and how they go about saving you energy. Diode, the base word for LED, is a microscopic electrical component that only allows current to flow through it one way. This is also true for a light-emitting diode. If electrical current flows through the LED one way, it will emit light. However, no current will flow if electricity tries to go the opposite way. This happens because as electricity flows through an LED, photons are released. Photons are the most basic unit of light. As electrons drop into microscopic holes in the diode, energy is released in the form of photons. There's a gap between the electrons and holes. This gap width determines the color of the light given off. If the gap is very narrow, the frequency of the photons is small, and the light is invisible to the human eye. This infrared light is perfect for remote controls. If the gap is wider, the frequency of the photons will be larger, allowing LEDs to emit visible light. LEDs are constructed in a way that maximizes the efficiency of a diode. The plastic bulb encases the diode in order to direct all light out of the rounded top, unlike a light bulb. This is one of the ways LEDs save us electricity. The efficiency of LEDs has been researched for many years. Several studies have been conducted at the Bell Laboratories in the USA and the Royal Radar Establishment in England since the 1970s. Scientists test voltage in volts, light luminosity, or its intensity, which is measured in lumens per watt, the wavelength of light created, measured in micrometers or nanometers, which determines its color, and how much electric current a circuit component uses, measured in amperes. At Bell Labs, state-of-the-art digital multimeters, seen here, and oscilloscopes, as seen here, are used to accurately detect many of these variables. Electrical noise from unwanted static, magnetic fields, electromagnetic waves, or other interferences gets eliminated as best as possible because LEDs are tested in large quantities. Testing many LEDs at a time also accounts for defects. LEDs can be great for saving energy in a variety of forms. When compared to incandescent lights, LEDs are much more power efficient. As of now, LEDs are more energy efficient but less bright than fluorescent lights. Today, LEDs are being used in television sets, monitors, and laptop screens as the backlight source. Using LEDs here help make TVs, monitors, and laptops more power efficient, thinner, and run cooler. An LED TV can save you around 40% in energy bills compared to plasma TVs. As you've seen, you can also buy household lights that work using LEDs. Soon, many phones will also be lit by LEDs. Let's recap on some of the things we've learned today. Compared to other lights, LEDs in development are the most energy efficient. Incandescent, the bulbs with filaments, are the least efficient. Many technologies around us use LEDs, like these we've shown. We've also learned that a lumen measures the brightness of light, wavelength measures the distance between two crests in a light wave, which determines its color, a volt measures the potential difference between 2 points, and an amp measures how fast electrical current is traveling, like a river. Current flows only one way through an LED as seen in this video. When current is flowing, electrons fall into holes, and when they connect, photons are released. These holes are a key part of the LED. So stay on the lookout for new LED lit technology, and with it, we'll be running a cooler, more efficient world.